So okay, that's the basic idea. Oh, wait a minute. I really should take this out, actually, because this is kind of... Okay. Right. I think... This is where you want to be, the current understanding of what they are.
That may make it easier for me.
Okay, I'll tell you what the current understanding, or the current pictures that we have of electron. So what I had here in the introduction was really the rest of the quantum bicycle project. I'll go through it very quickly and say what I was going to say. Mm-hmm. That's the picture. This is taking these double loops and having a look at what an electron looks like in this model. So this is looking in more detail at this shape. And I've put some smoke rings in here just to show how this motion goes round a toroidal shape. This is like a donut, like a sausage, and it's on the surface of that series of smoke discs. So the series of smoke discs, if you imagine them coming through here, form a toroidal shape if I extended the smoke discs. And then the stuff gets projected down to a spherical thing in the reality in which we observe things. So this is, I mean, it's a donut. It's like you know what a donut looks like? It's a curved surface, but it's a curved surface with a hole in it. Mm-hmm. So it's a torus is donut shaped. So donut's got it's a ring with a hole. Let's make one. Yeah, bagel's just what you need. It's okay, I've got plasticine here. Make anything. So I'll make a slightly smaller one, I think. Okay, so you have something which is ring shaped, like that. And what happens is this motion takes place over the surface of a ring. It comes in and out over the surface of a ring. Want to see what it looks like?
Yeah.
Four-dimensional rotation. Just a minute. Let me just come out of this and go over here. Here we are. So what this is you know, okay, this is going to blow your mind slightly, but that's okay. Don't worry about it. Right. So imagine a bicycle wheel, and the bicycle wheel's going round and round. Mm-hmm. Okay. So it's rotating like this, and that's a two-dimensional rotation. It's a rotation in a plane. Now, in 3 dimensions, you can't have 2 rotations happening. If I try and rotate that thing so it's rotating about the axle. But imagine I try to put another axle into the thing and have it rotate about that as well. Right, stick a spoke through the wheels. Mm-hmm. Doesn't work. Mm-hmm. Bicycle wheel stops rotating. You can't have 2 axes of rotation about which it's rotating at the same time. You could spin the whole bicycle and things, but that's not what I'm talking about. I'm talking about having a separate rotation about in a completely separate plane. Why?
Like a gearbox?
Well, no, not like a gearbox, because I'm talking about having a rotation. If I'm rotating like this in a plane, that plane's got 2 dimensions in it, and the rotation's happening in the two dimensions. If I want to have an independent rotation, I've only got one more dimension. So, because I've only got 3D. So you can't have 2 rotations going on at once in 3D, because you've only got one. Because if the rotation's happening in a plane, there isn't a separate plane not connected to this plane. You've always got to have part of that plane too. But in 4 dimensions, and space as time is 4-dimensional, you have got a separate plane. If this is the XY plane, I've still got the ZT plane I can rotate in. So what that is that's a motion. Now, that's hard for us humans to do, but it's easy for a computer. So so you just say, okay, there are 4 dimensions. It goes, yeah, sure, 4-dimensional vector, no problem, just extra component. So what you then do is you do 2 rotations and you project them. Okay, and this is what happens. This is what, look at this thing here. Look, I can make this thing longer or short. This was actually done by a guy called Fergus Murray. I downloaded it. It's open source, so I've modified it to be able to do this kind of thing. So I don't know if you can see that little thing wobbling around just there. You see what it's doing? It sort of looks. This is a projection of a 4D rotation. But let's make it longer so we see what it starts.
Blowing in the wind.
It does, doesn't it? But look if I make it longer. Look, there it is. Do you recognise that shape? It's that thing. Okay, now I'm going to make it longer. I'm going to let it keep on doing this. Right, so I'm just making it longer than one thing. So I'm following the path, just making the path go for longer. You're looking at a 4-dimensional rotation, but then projected onto the screen and project into time. Look what it's doing. Can you see it's kind of like it's folding around something? What it's folding around is something like that, a torus. So the rotation is going around this, but then as it moves around, you're looking at different projections of this. And if you imagine something, imagine a ball, a sphere. sphere of metal, three-dimensional sphere. Imagine a circle. I can make that two-dimensional, squash it down, it's just a circle of metal. Turn it into a sphere, it's a three-dimensional thing. I can do that again. I can make it mathematically, on the computer, make it four-dimensional. And then if I look at and that's what I'm doing here, I'm looking at the projections of something going around that four-dimensional sphere. So, and those projections have two forms. One of them is, well, just like if I take a sphere and I project it straight down onto a surface just here, I'll get a circle. But if I take your light and I project it that way, I'll get an ellipse, or a different kind of shape. So circles don't just produce circular projections onto a plane, they can produce things that are elongated as well. Try it. When you do that with 4D, you can get circular, spherical. So a 4D sphere goes down to a 3D sphere in one projection, but on any other projection it goes to a torus. So projections there become toroidal, they have a hole in them. So the projections of a 4 sphere are either toroidal or spherical. And that's what you can see here on this flat thing here, that it's really just, it's going around a torus. And you can show that mathematically as well and prove that it's a surface, but that's a bunch of heavy maths, so why would you want to look at that? This is much more fun. And actually the maths isn't very complicated, it's just a few sine waves, sines and because all a circular motion is it's x is a cosine wave and y is a sine wave. So if you do x is cos theta and y is sine theta, it just describes a circle mathematically. So these are just sines and cosines, and all you do is, instead of having two of them, you've got four. So it's not particularly hard maths. But we're stupid humans, so it's very hard for us to see 4D, but it's not hard for the computer to generate it and then project it.
Because I've never seen.
We've never been outside 3D, have we? No, and we never will, because the world is three-dimensional. It's not four-dimensional, despite, which we'll come to later.